In this video, I am going to define some operations on functions. I have two functions, f of x is equal to 3 over x plus 7 and g of x is equal to negative 2 over x minus 7, and I need to find the f plus or f minus g, that means sum and difference, and then product f times g, and then f over g or the quotient f divided by g. I'm going to do this one by one. So number one is going to be my f plus g of x, which is by definition f of x plus g of x. Now my f of x is this 3 over x plus 7, and my g of x is negative 2 over x minus 7. Now I need to combine these two terms using the LCD. So LCD of the denominators is going to be x plus 7 times x minus 7. So I need to multiply the first term by x minus 7 and multiply the second term by x plus 7. If I do that, I get the following. I get this. So 3 times x minus 7 divided by x plus 7 times x minus 7, plus negative 2 times x plus 7 divided by x plus 7 times x minus 7. Now I have the same denominator, so I can combine them. But before combining them, I am going to simplify this using the distributive property, and similarly this using the distributive property. If I do so, I get the following. Now please look at this. So 3x minus 21, that comes from here using distributive property, and then negative 2x minus 14, that comes from here using the distributive property. Now if I go one step further, I get the following: x plus 7 times x minus 7. Now this becomes 3x minus 2x is gonna be just x. Negative 21 minus 14 is gonna be negative 35, and that's what the new function f plus g looks like. We are almost done. However, we need to consider the domain of the new function. This new function that I got, what is the domain of this new function? Let's look at the domain of the original functions, f of x. It's a rational function, so we need to look at the denominator. We see that if x is negative 7, then this function f is undefined. So the domain of this function is all the numbers except for 7, except for x is negative 7. Similarly, for g of x, the domain is all the numbers except for x is equal to 7, because if I plug in x equal to 7, the denominator becomes 7 minus 7 is 0. So now that I'm combining these two functions, so I will have a new domain, by the way. Okay? And the new domain for the function f plus g is going to be, look at the denominator and see what values of x is going to be making the denominator 0. As you can see, x is equal to 7 is going to make it 0, because this is going to make that 0, and then doesn't matter what it is, 0 times a fixed number is 0. On the other hand, when x is equal to negative 7, then this is going to be 0, and in that case this is going to be some other fixed number. So product of a fixed number and 0 is always going to be 0. So the domain of the new function must exclude these points. So meaning you want all the numbers on the number line except for negative 7 and positive 7. So you want everything in between, everything to the right and everything to the left. And you could put it in interval notation. It's going to be negative infinity comma negative 7 union negative 7 comma 7 union 7 comma infinity. And that's what the domain of the new function is. Now I'm going to talk about the subtraction of these two functions. So f minus g of x, by definition we have this. So it's exactly the same process as the first one, f plus g. So only thing you need to be careful here is that this negative, and there is a negative in front of the function, in the given function. So these two negatives multiplied together is going to give you a positive. And then everything else is straightforward, finding the LCD and combining the like terms, and finally you get this function. However, again we have to look at the domain of this new function, as it turns out that the denominator has x plus 7 and x minus 7. So if x is plus or minus 7, the denominators are going to be 0. Denominator is going to be 0. In that case, the new function will be undefined, and you want to avoid those values. So the domain of the new function is going to be the same as the domain of this function, this one, f plus g, which is this. All the numbers on the number line except for positive 7 and negative 7. Finding the product is kind of easy for these two particular functions. F times g of x is f of x times g of x. This is my f of x and this is my g of x. If I multiply it, it's going to be negative 2 times 3. Negative 2 times 3 is negative 6 divided by x plus 7 times x minus 7. So the domain of this function, new function, is going to be still the same as this domain. Okay, this one. All the numbers on the number line except for plus 7 or minus 7, because if you enter plus or minus 7 for x value, denominator will become 0. In that case, this new function will be undefined. So you want to exclude those two functions. And division is kind of easy as well. F divided by g of x is f of x divided by g of x. This is my f of x, this is my g of x. Now this is like dividing a fraction by another fraction, so this one in the denominator is gonna flip, meaning you have to find the reciprocal. So what happens, x minus 7 goes on the top, and then if I simplify it further, don't forget this negative sign, is gonna be negative 3 over 2 times x minus 7 divided by x plus 7. Now if we look at this function, new function, our domain is actually different. For this function, only x value that's going to make the denominator 0 is when x is equal to negative 7. So we want all the numbers on the number line except for x is equal to negative 7. So this is negative 7. So I exclude that point but include everything else to the right of negative 7 and to the left of negative 7. If you want to put it in the interval notation, it's going to be negative infinity to negative 7 union negative 7 to positive infinity. Now let me summarize what I have done. I have taken two functions here, f of x and g of x, and kind of combined them in different ways, or created new functions from these two functions by doing function addition, function subtraction, function multiplication, and function division. In the entire process, what we needed to keep in mind is that we need to be careful about the domain of the new function, which will not be the same as the domain of the original functions. But sometimes it may be, but not necessarily always. In this particular example, the one we get, none of these are actually the same as the domain of the original ones. So we have new domains for each of these operations: addition, subtraction, multiplication, and division. I hope that this discussion was helpful. Thank you very much.